Durukal. I'm a quality assurance engineer, and as most of the other quality assurance enthusiasts, I'm interested and involved in test automation in my daily life activities. As most of the other quality assurance engineers, because nowadays test automation is a great part of testing. Of course, quality assurance is not only testing, and testing is not only test automation. But with only manual testing, we cannot perform all the needed activities in time and efficiently. That's why maybe we need test automation for the continuous testing activities. And not only that, but test automation has lots of different great advantages. For example, it reduces execution time, and it already reduced the manual effort since we can replace some automated testing activities with the manual efforts. And maybe we can perform some activities which cannot be done with only manual effort and manual activities. For example, we can create lots of different virtual machines, and we can allocate lots of different resources for our testing activities, and we can do the load testing and concurrent request performs to test the functionalities and the non-functional aspects of our service and other parts of our products. So it is great. It has lots of different advantages. But of course, this is only the bright side of test automation. So there are lots of different challenges and difficulties that we should get rid of somehow in some ways. And even if we perform in a way the test automation activities, then maybe there will be some issues which will not be solved by this kind of test automation activities. So let's start discussing one by one what difficulties we may encounter in our test automation activities and how we can get rid of them, how we can cope with them. So there may be lots of different reasons. For example, some of them stemming from the product or the way that we are following to develop these products. For example, we are mostly doing the agile practices nowadays. And as we know, agile is very open for change or updates. But whenever we have some updates to the behaviors or the specifications on the product, then we have to update our test cases accordingly. Because otherwise, if the behavior is already updated and we do not keep our test cases up to date or aligned with the behaviors, then maybe we will be missing some coverage. Some aspects of the use scenarios will not be covered by our test cases because it was already changed, but we didn't update our test cases. So we have to take care of our test cases continuously. And if there's a change or update in the behaviors, in the expected results, then we should accordingly update our test cases. So this challenge is raising from the continuous maintenance. So how can we cope with this difficulty? Of course, a very strong communication channel is needed for this, because if we are not aware of what is being updated, what has been updated, or what kind of change is done on the behavior, then we cannot update our test cases because we are not aware what has been applied on the behaviors. So if we have a close and strong communication channel and the QA teams or the QA members are involved in the development activities from the first stage, from the first place, then they will be aware of what has been done and they can already start their preparation in the meantime. So this is why we are always saying quality is not an individual effort, but it can be done or it can be achieved by a holistic team approach. The whole team should be on the same page and they should be focused all together on quality. So even if there is a change, even if there is a slightly updated behavior or an expected result which will be supposed to be used by the end users, then all the parties should be informed and they should be all working on the same practices, fully aligned on the same page. So there may be some other behaviors which are tricky to automate or to even test. For example, there may be some instabilities like stemming from lots of different reasons. For example, if we are performing A/B testing activities, maybe we are doing canary deployment, which means we are installing different versions of the product on different instances. So in that case, we will not be knowing which instance we will hit during the testing activities in advance. So we may see lots of different actual results. So it will be difficult to match with the expected result. Not only this, but the behavior itself may be conditional, which means According to some user inputs, it may trigger some behaviors, but according to some other data ranges, it may trigger some other expected results or other expected behaviors. So we should prepare our test cases accordingly to all these conditional results or conditional aspects. And we may be encountering some different variations of the behaviors or the aspects of the products. So we should design our test cases very well and in a proper way to cover all these aspects properly. Sometimes it is even not possible to test some behaviors or the aspects of the product. We may have some testability issues. For example, if we are testing a subsystem of the whole system, and if we have some dependencies on the other modules or components, sometimes maybe we will not have the access to all the data or the input that we need for this testing activity. So what we can do, of course, we can mock some other parts of the system, but the mocking will not be the same as the production usage. So sometimes we will need to ask the development teams to implement some additional interfaces, public interfaces, to access the data that we need. So again, the collaboration is very important to building a close communication channel and asking for additional interfaces just for testing purposes. We know that they will not be used in production environment. It will not for the end users, but just for testing purposes, we can ask to implement these interfaces from them. And similarly, if we have some hardware issues, these will be a little bit tricky to automate. We can somehow test in manual ways, but if we are doing the test automation, then it will be difficult to simulate these kind of use cases for the hardware modules. For example, if we have some physical robots in our solutions, then there will be some behaviors or the requirements which should be implemented on these robots. For example, in my last project, I was testing a warehouse automation solution. So we were deploying some physical robots, and they were moving around. So one requirement was, if there's an obstacle in front, then the sensors should detect them and the robots should move around. So how can we test this? We can test this manually, but if we are doing the test automation, it is a little bit tricky and challenging. Of course, we can make use of the simulation, but it will not be the same. So the physical dimensions and lots of different environmental conditions, not only the image sensor, but there will be lots of different sensors will be triggered from the environmental conditions. So in addition to the test automation, sometimes the manual testing will be supporting our testing activities, not to overlook any issue or any vulnerability in our solutions. And nowadays AI is an important part of the systems or products that we are developing. So it is very high likely to see some AI components in the systems that we are using or developing. So for example, if we have a sorting algorithm on the web pages, then how can we ensure that really the most similar items are shown in order? So the performance of the AI algorithm can be evaluated during the implementation of the AI model itself, and we can train and generate a model. But in the functional testing level, it is not easy. So sometimes we should make use of the other verification and validation methods, not only the testing, but maybe the review of code, review of design, and simulation, and some other verification and validation methods we can utilize in our activities. Also, different aspects of the product we have to consider to ensure the quality, because functionality is not the only aspect of the quality, but also we have the understandability, we have the usability, we have the maintainability. So we should consider lots of different aspects of the product. For example, especially for the negative cases, if the user does a mistake, there should be some warning, there should be some error messages. So we can easily ensure that the error message is there, maybe the pop-up window is there, but how understandable the error message is, if the user is able to understand what is happening there. These kind of usability or the understandability issues we should ensure, and we can make use of different non-functional testing activities as well. So we can use different frameworks to support our functional test automation as well. So for the first part, in the first part, we went over lots of different reasons or difficulties making automation a little bit difficult. mostly stemming from the product or stemming from the activities that we follow to maintain our life cycle. But also there may be some challenges stemming from the implementation itself. So sometimes even before starting the implementation, we have to set up our environments. So sometimes we have to do the configuration, we have to use different cloud provider services maybe, we have to maybe set up email relays. There may be lots of different environmental preparations. So even these are challenging and tricky, and it is time consuming. There will be even a learning curve. We have to learn the usage of the services that we are using, the platforms and the provider services we have to learn and to make use in our activities or the test environments. And even after starting the implementation, of course implementing the algorithms that we need is difficult, it will be challenging, and especially for the UI automation, sometimes we will be struggling to build the implementation in the best way, because we will have to locate the elements in an efficient way. It should be robust and reliable. After the design of the page is updated, the test should not be broken. So we have to find a way to maintain our test cases in a proper way. So again, what we can do is maybe we can talk to the development teams, and whenever they design a new element to be placed on the page, they can add some unique IDs. Not because if we use only the expats or the class names, they can be updated frequently. So the development teams may change them often. But if there is a data test ID or any other unique ID, even if the design of the page has changed, then our test cases will not be broken. Again and again, the collaboration and the close relationship to the other teams and the holistic team approach is again the key factor for success. And after the test cases are implemented, of course, we are supposed to execute them on the pipelines and maybe before each merge to ensure that the changes or the pushes or the updates are not breaking anything. So the execution duration is very important. For each merge request, if we are waiting all the executions for a long time, then everyone will start complaining. So what we can do is, or what we should do is, to reduce the execution duration as much as possible. So maybe we can do the timing analysis, and we can figure out what kind of tests or which test cases are taking the most time. So if we have any dummy weights, or if we have any redundant code which is really not needed to ensure or to assert the actual result with the expected result, then we can remove them. And we can of course create lots of different virtual machines to perform the parallel runs. So we can reduce the execution durations as much as possible. And not only the execution duration, but also the code quality is very important in our test automation framework, because if we have some duplicated codes, there will be some extra maintenance effort, because there may be some false alarms from time to time. All the reported issues will not be real bugs, but some of them will be false alarms. So to cure these kind of test smells that we may have in our environment, removing the duplication is very important. So we should continuously ensure the quality, not only in our product, but also in our test automation framework as well. So we can use some static code analysis tools, or of course we can use the peer reviews. So in lots of different ways, we can improve the quality in our test automation framework. There's lots of different difficulties or challenges that we can encounter in our testing activities. It may look a little bit scary, but of course there are lots of different solutions as well that we can apply against these problems or difficulties. So we discussed about the importance of building a strong and reliable test automation framework. So it's very important to avoid the anti-patterns and to apply the best implementation or development practices, and embracing some good implementation practices. And not only the test automation framework itself, but also the whole testing environment is very important. Sometimes we have to do the troubleshooting, we have to analyze the test results. So it is very important to collect the execution details and the evidences. So then we can maintain the test failures or the false alarms or even the silent horror cases that we may have. So in this way we can improve the reliability of the test automation framework. So we may have lots of different variety of difficulties or challenges, but after doing the root cause analysis, we can figure out what kind of solutions that we can apply. And by communicating to different parties, different teams, or the teammates, we can develop some common solutions all together. So in this way, we can achieve the quality as a team effort. So I wish everyone having a strong, reliable, and robust test automation framework, and without any testability issues, without any escape bugs. I wish everyone happy testing.